Hello. All right, here we are for the Unit 1 review number 2. Okay, so you've gone through review number 1, so hopefully you've had some practice, so when you see these problems, you're not confused automatically when you read it. Because, yeah, some of these problems, the way they're presented, they seem a little like, huh? But then once you're like, oh, okay, this is what it wants me to do, then it's not so bad. Okay, number 1. What is the recursive formula? So they want a recursive formula for the sequence that is given by the explicit formula this time. Okay, so last time we were given a recursive formula and we had to find the A1 and the common difference so we could write the explicit formula. And now we're given the explicit formula and we have to write the recursive formula. So the explicit formula, if I can get it out, says a sub n equals negative 4n plus 1. Okay, so the number in front of the letter, that's the slope, right? Remember, slope is the same as the common difference. So this tells me that d, the common difference, is negative 4. Okay, I also need the first term from this. So if I plug in a 1 for n, that will give me the first term. So negative 4 times 1 plus 1. Well, negative 4 times 1 is negative 4. Negative 4 plus 1 is negative 3. So I have the first term and I have the common difference. So now I can write the recursive formula. The recursive formula, we always have to give the first term. So a1 equals 3. The second part is the recursive formula part. So a sub n equals a sub n minus 1, the previous term, plus the common difference. But since the common difference is negative, we can just put minus 4. And there is the recursive formula. Okay. Number 2, skip. Number 3, skip. Number 4, write an explicit formula. So this time we have to write an explicit formula for the nth term of the sequence 8, 2, 0.5, 0.25. So first of all, is this arithmetic or geometric? Well, are we adding the same number, adding or subtracting the same number each time, or are we multiplying by the same number each time? Well, to get from an 8 to a 2, we'd have to subtract what, 6? 8 minus 6 is 2, but 2 minus 6 is not a 0.5. 2 minus 6 would be a negative 4. So it's not arithmetic. This has got to be geometric. It's geo. Okay, so what are we multiplying by? Well, I know that 8 divided by 4 is 2, and 2 divided by 4, well, 2 over 4 reduces to 1/2, so 0.5. So it looks like we are dividing by 4. Well, dividing by 4 is the same thing as multiplying by a 1/2. Half of 8, I'm sorry, a fourth, why did I say half? A fourth of 8 is the same as dividing by 4. So a fourth of 8, 8 divided by 4 is 2. A fourth of 2, a quarter of 2, is 0.5. 1/4 of 0.5 is 0.25. What's another way that we can write 1/4 but as a decimal? 1/4 as a decimal is the same as 0.25. Okay, so you could also use that as well. So you can also always convert to decimal, okay? And so we're writing an explicit formula. We have the first term of the sequence is an 8. We have the common ratio. R is a 1/4. You can write it as a fraction or you can write it as a decimal. And we are ready to write this explicit formula. So remember, the explicit formula for a geometric sequence is a sub n equals a1 times r to the n minus 1 power. So for this one, using this particular situation, we're going to use this formula, but we're going to plug in what we know for a and what we know for a1 and what we know for r. So a sub n equals a1, the first term was 8. The common ratio is a 1/4, or you could put 0.25. I'll put 0.25 to the n minus 1 power. And that is the explicit formula. We're skipping numbers 5 and 6, so time to turn that page. We're also skipping 7, so we're on to number 8. So for number 8, it says the rectangular box with a square base has length and width equal to W. The sum of the length, width, and height of the box is 20 inches. Write a function that represents the volume of the box in terms of the width. All right, so when in doubt, draw it out. We need to draw a picture. So I'm going to do my best to draw a rectangular box, and it says it has a square base. So the top base and the bottom base must look like a square, but the box itself is rectangular. I'm actually really proud of my drawing right now. So woohoo! Okay, so in our drawing, let's label some things. It says it has a length and a width equal to W. Length and width. So the base has a length, that's W, and a width, that's W. Okay, and the sum of the length, width, and the height of the box is equal to 20 inches. Okay, so length, width, and height, since length and width are both the same variable, we would write W plus W plus the height. So length plus width plus height equals 20 inches. All right, we're going to write a function that represents the volume of this box. But first, we got to figure out, okay, what is it in terms of the width? So let's go ahead and solve for height there. Okay, so we need everything to be in terms of width. So we need our only variable to be the W. Okay, so we have two W's there. 2W plus H equals 20. And let's go ahead and subtract 2W from both sides. And H equals 20 minus 2W, or you could write that as negative 2W plus 20. Same difference. Okay, so now we have something for height. Okay, this is going to come in handy. Because remember, what are we dealing with? We're writing a function to represent volume. What is the volume formula of a rectangular prism? Well, volume equals length times width times height. Okay, so the length would be W. The width is W. And the height we just found right here, 20 minus W. So I'm going to substitute that in. Because it's a quantity, we have to use parentheses to hold that quantity. So volume equals W times W is W squared times 20 minus 2W. And let's go ahead and simplify this out. So that means we need to distribute the W squared. So V equals W squared times 20 is 20W squared. W squared times negative 2W is a negative 2W cubed. There's our answer. So there is our function to represent the volume of this box in terms of the width. All right, so number 9, the design of a spherical Christmas ornament has volume of V of R equals 4/3 pi R cubed times 6 minus 2R. That should be an R, not an X, because everything was in terms of R there. As shown in the graph below, where the radius must be less than 6 centimeters. Okay, so we have our graph. What is the max volume of the ornament in centimeters cubed? Okay, so we're going to look for that max volume, and the radius has to be smaller than 6 centimeters. So it's going to be somewhere in here. That's going to be our max volume. Let's see what we get. So remember, to find the max volume, that has to do with looking at what are our restrictions. Okay, we're talking about volume of an ornament. So volume can't be 0 and volume can't be negative. So let's take that 4/3 pi R cubed times 6 minus 2R, and let's find the zeros. So let's break apart the factors and set them each equal to 0. So pi is considered a a constant. So the 4/3 pi is a constant and the r to the third is a variable. So 4/3 pi r cubed, set that equal to 0. And 6 minus 2r, set that equal to 0. Well, if I divide both sides by 4/3 pi, 0 divided by anything is 0. So we'll have r cubed equals 0. Cube root both sides, r is going to equal 0 no matter what there. Over here, we'll have 6 equals 2r after I add 2r to both sides. Divide both sides by 2, and r is going to equal 3. So these are the things that r cannot equal. R cannot have a radius of 0. R cannot have a radius of 3 because that will, when we plug those values in, it makes the equation go to 0 and volume can't be 0. So now I know what my domain is. I have numbers from 0, 1, 2, and 3. And I can't use 0 and I can't use 3, but I know what I'm limited down to. So it's got to be a 1 or a 2. So let's try those out. Let's plug in a 1 and see what the volume will be. And let's plug in a 2 and see what the volume will be. And whatever one is the biggest one will be the max volume, and that will be the answer. So V of 1 equals 4/3 pi times 1 to the third times 6 minus 2 times 1. Okay, well, this will be 4/3 pi times 1 is just going to be itself. And then 6 minus 2 is a 4. So 4/3 pi times 4 pretty much. Okay, well, if I put that 4 over 1, this will basically be 4 times 4 is 16 over 3 times 1 is 3, 16/3 pi. Well, what is 16/3 pi? Well, 16 divided by 3 is 5.3333333. Multiply by pi, and I'm going to get 16.8 if I round that to the nearest tenth. So wavy equal sign, 16.8 centimeters cubed. Okay, let's try when we plug in a 2. So V of 2 would equal 4/3 pi times 2 cubed times 6 minus 2 times 2. 2 to the third is 8. So I will have 8 times 4 is 32. So 32 over 3 pi. And then 6 minus 2 times 2 is 4. 6 minus 4 is 2. Okay. So when I multiply in that 2, 2 times 32 is 64. So 64 over 3 pi. Grab my calculator. 64 divided by 3 is 21.33333 times pi would be 67.02. Centimeters cubed. Well, we can clearly tell which one is bigger. So what is the max volume of the ornament in centimeters cubed? 67.02 centimeters cubed. That one is the biggest volume it will be. And there we go. Next one, number 10. Sketch the graph of a cubic function with a positive leading coefficient and a y-intercept at -5. So we want a cubic, so that means we want an x to the third. We want it to have a positive leading coefficient and a y-intercept at -5. So let's write an equation. So let's have y equals, we need a cubic and it needs to be positive, but it needs to have a y-intercept. And we know the y-intercept is just the constant on the end of the equation. So -5 because it needs to be at -5. Okay, well that's easy. It's basically the parent cubic function shifted down 5. So 1, 2, 3, 4, -5 would be down here. So I know that this is shifted down to here. And this is a positive cubic, so we use the slope. And since that leading coefficient is a +1, I'm going up 1 over 1 in that direction and down 1, left 1 in the other direction. And I have my cubic. Okay. So there's an example of one. And then over to the side, it says, can you do another that looks different? Yeah, we can totally do that. So it's got to have the same conditions. So we've got to have an x cubed, and it's got to go through a y-intercept of -5. So all we can really change is the coefficient number. So let's like change it to a 3x cubed, because that's going to be our slope. So it's still down at -5, 1, 2, 3, 4, 5. But this time our slope is a 3. So go up 1, 2, 3 over 1, and then down 3. I need to add those in there, and then left 1, down 1, 2, 3, left 1. So it looks different because it's just skinnier. This one is more elongated. This one is like squished in with the y-axis there, so it's skinnier. It's been stretched out. All right, number 11, describe the end behavior of the graph of -5x to the third in nerd language. So that basically means, okay, -5x to the third. So we've got a negative leading coefficient, and it's to the third power, which means this is an odd degree. Okay, so negative odd, if I draw a quick little sketch, that means it's going to be going up on the left and down on the right. Okay, so in nerd language, that means with the arrows and the approaching and infinity and negative infinity, that's what that means by nerd language. So we can say as x approaches -infinity, so as x is going to the left, the y is going up. So y goes to infinity. And as x approaches positive infinity, so as we go to the right, our y is going down, so y goes to -infinity. And there's our nerd language. See, we can speak nerd. Number 12, it says classify each polynomial, function in the table as an even function, odd function, or neither. Select exactly one answer in each row. Okay, so we have x squared minus 2x, that would be to the first power, plus 3, that would be x to the 0 power. Even though it's not written, we assume it to be that because anything to the 0 power is 1. 3 times 1 would still be 3. Okay, so I have an even, an odd, and then an even. So it's all or nothing, guys. So this one's a neither. In fact, I want to color that in. I think it looks nicer. All right, next one. We have a 4x to the 5th minus x to the 1st. Power of 5 is odd. Power of 1 is odd. So this one is odd. (2x² plus 7). Well, the power of 2 is even. And that 7 technically has an x to the 0. The 0 power is also even. So this one is even. X to the 3rd plus 5. Well, 5 is a constant, so it technically has an x to the 0 power. 3 is an odd power. 0 is an even power, so this one's a neither. So this went neither, odd, even, neither. All right, skip 13 on to 14. Javier divided the polynomial x cubed minus x squared minus 5x plus 1 by the polynomial x plus 3. But his solution is incorrect. Go away here. It is incorrect. So that means we need to find Javier's mistake. Here's his work shown, and there's different lines that we're going to be looking at, lines 1 through 6. Which line contains Javier's first mistake? All right, let's take a look. Well, we're doing my favorite, polynomial long division. So to get an x cubed, we need to multiply x by something. Well, that something's got to be x squared. X squared times x is x cubed. X squared times 3 is a 3x squared. And then we have to do the sign change. So this will be negative and this will be negative. These will cancel. Negative x squared minus 3x squared is negative 4x squared. So far, so good. And then you bring down the negative 5x. And then you do it all over again. So what do we multiply by x to get negative 4x squared? Well, we're going to need a negative 4x. Negative 4x times x is negative 4x squared. Negative 4x times 3 is negative 12x. And then we're subtracting, so we have to do a sign change. So that's going to change this negative to a positive and this negative to a positive. Okay, so negative 4x squared plus 4x squared, those cancel. Negative 5x plus 12x is not negative 17x. Negative 5x plus 12x should be 7x. Okay, so here is where the mistake is at, line 4. So let's look at letter C and see what it says to make sure. Line 4 should be, yeah, that should be a, yeah, it should be a positive 7. Like, which one should it be? Should it be negative 7 or positive 7? So, yeah, it should be a positive 7x. So this is incorrect. It should be a positive. So line 4 should be positive 7x plus 1. So it is letter D. Notice how those little tiny details can determine if we're going to get it right or get it wrong. So we got to be careful about that. All right, number 15. Fully factor 3x cubed minus 12x squared plus 9x. And from the get-go, we should notice that there is a greatest common factor, and we need to factor that out first before we try to do product sum. Because if we try to do product sum right now, it's not going to work. So let's factor out the GCF. Looks like there's a 3 in common with all 3 terms, and they all contain an x as well. So let's divide out that 3x. 3x cubed divided by 3x is an x squared. Negative 12x squared divided by 3x is a negative 4x. 9x divided by 3x is a positive 3. And now we can do product sum. So the product would be 1 times 3, which is 3. It's got to add up to negative 4. So let's see, 2 numbers that multiply to 3 and add up to 4, it's got to be a 3 and a 1. And to get a negative 4, they're both going to have to be negative. Because negative times negative is positive. Negative 3 minus 1 is negative 4. These are the droids I'm looking for. And it's an easy trinomial. Don't forget about the 3x that's out front. So we're going to have an x and a minus 3 and an x and a minus 1. And now it is fully factored. And there you go. Number 15. Number 16, factor x cubed minus 64. Well, this is a difference of cubes. So that means that we're going to need to use that special formula. So for a difference of cubes, I'll put it over here on the left. So anytime you have a cubed minus b cubed, it factors down to the minus plus plus. So a minus b times a squared plus ab plus b squared, minus plus plus. So this is the little formula that we're going to be using. I recommend writing down the sum of cubes and difference of cubes formulas so that you have them in front of you for this test. All right, let's do this. So x cubed minus 64, well, obviously x is being cubed, so that's my perfect cube. And to get a 64, what to the third power of 64? Well, that would be a 4. So this is my a and this is my b. So using that formula, then this will be a minus b, so x minus 4, times a squared, so x squared, plus a times b, so x times 4 is 4x, plus b squared, so 4 squared is 16. And that's it. We won't be able to factor the trinomial. Those are never factorable when we've done a difference or sum of cubes. Number 17. I'm not going to be able to fit the answer or my work for number 17 in this little tiny space, so I have a piece of scratch paper just ready to go. It says, write a polynomial f of x of 4th degree with 0, 0, negative 1, and 2 with a double root at 2. So this is a 4th degree polynomial, so that means that there should be 4 roots altogether. They gave us 1, 2, 3, but it says that there's a double root at 2. So that means that 2 gets repeated twice. Okay, so we need that. And we're going to write this over on my scratch paper. So 17. So I have a 0 at x equals 0, a 0 at x equals -1, a 0 at x equals 2, and it's a double root, so it happens twice. Happens double. Okay. So let's get to this. Let's work backwards. So the next step is to write, well, what would it have been in factored form? Well, when x equals 0, its factor is just x. Before it was x equals -1, its factor was x plus 1. Before it was x equals 2, its factor was x minus 2. And I have 2 of those. Okay, now we just have to multiply this out. So we do 2 at a time. And it doesn't matter which 2 we're going to start with. I do recommend that you wait to multiply in the x until the very end. Okay, so I'm going to do 2 at a time. I'll do the last 2. So x times x is x squared. X times -2 is -2x. -2 times x is a -2x. And -2 times -2 is a +4. We have like terms that we can combine. So that'll be x squared minus 4x plus 4. And let's bring down the rest of it. Okay. Well, remember we can only multiply 2 at a time, so let's go ahead and multiply the x plus 1 times the trinomial that we just got. So x times x is x cubed. X times -4x is a -4x squared. X times 4 is a +4x. Now the inside terms. 1 times x is a +x squared, so I'll line them up. 1 times -4x is a -4x. Ooh. 1 times 4 is a +4. When they're big like this, I like to stack them. That way they're already with their like terms and it's easier to group them that way. So I have an x cubed. -4x squared plus 1x squared is a -3x squared. 4x minus 4x, those cancel to 0. And then I have a +4. Okay. So now I have x cubed minus 3x squared plus 4, and we just have to bring down the last x and distribute one more time, and then we have our answer. Okay, so we're going to have, if I distribute that x times x cubed is x to the 4th. X times -3x squared is a -3x cubed, and x times 4 is a 4x. So the polynomial that this must have come from was x to the 4th minus 3x cubed plus 4x. And there we go. So let's go ahead and write that down on our sheet here. Now make sure if you do scratch work on a separate paper that you also submit pictures of that work, because no work equals no credit. So you got to make sure that you are showing me the work. So you know how people say, show me the money. I'm going to tell you, show me the work. That's your money for this class. Show me the work. Number 18. Samantha identified the graph below as the polynomial function f of x equals x plus 2 times x minus 2 times x plus 1. Explain why Samantha is incorrect. Oh, she's wrong. Why is she wrong? Well, let's take a look at the graph, because she came up with this equation based on what she saw in the graph. So let's see what happened. Okay, so I see the zeros. We have a 0 at -2, so we know that x equals -2. We have a 0 at -1, so we know that x also equals -1, and a 0 at +2. Okay, so I see the factor of x plus 2, factor of x minus 2, and factor of x plus 1. I see all that. Okay, so those are the correct factors, but if I were to multiply these out, I'd have an x times an x times an x, so I would have an x to the 3rd. So this, her function is stating that it's a cubic function, but on the graph, is that a cubic? Look at the end behaviors. They're both facing down on the left and the right. So this is an even degree polynomial. It's not an odd degree polynomial. So that's the problem. So Samantha's equation is an odd degree polynomial. But the graph shows it is an even degree polynomial. So the reason why I had to come up with a sentence here is because of this word explain. Explain why Samantha is incorrect. So anytime you have to explain something, you have to write up a response, and it needs to be clear and concise, straight to the point. I don't want an essay or anything, but I definitely want all the information to be presented in your response. All right, number 19, list the possible rational roots of f of x equals 5x cubed minus 2x squared plus 3x minus 3. So when we're finding the possible rational roots, we're looking at two things in an equation. We're looking at the constant, and we're looking at the leading coefficient. That is how we're going to find our PZs, the possible zeros. So let's find our PZs, because that's what they want, possible zeros. So they're always a fraction, or it's going to be a fraction. I need the factors of the constant in the numerator and the factors of the leading coefficient in the denominator. So factors of -3 are plus or minus 1 and 3, and that's it. Factors of the leading coefficient of 5 are plus or minus 1 and plus or minus 5. That's it. Okay, well now we need to split these up and make our list proper. So we're going to have plus or minus 1 over 1 is 1. 1 over 5 is a plus or minus 1/5. 3 over 1 is just 3, so plus or minus 3. And 3 over 5 is plus or minus 3/5. And there's our list. So we have 1, 2, 3, 4, but we're taking their positive and negative versions, so that's technically 8 possible rational roots. Number 20. When the polynomial f of x is divided by x minus 1, the remainder is 4. When f of x is divided by x plus 2, the remainder is 0. Which of the following describes the graph of the function? So they're giving us some information here. They're saying when f of x is divided by x minus 1, that means that x equals 1. The remainder is 4. Well, the remainder has to be it's the output. So that means that the y value equals 4. So basically when x is 1, y is 4. Okay. When f of x is divided by x plus 2, so that means that x would equal a -2, the remainder is 0. So that means y equals 0, divided evenly. So that's a 0. That means that when x is -2, y is 0, -2, 0. Okay, so now that we've picked apart what they have actually given us, now let's look at which one of these is true. Okay, so which one of these is describing the graph of the polynomial? Letter A has an x-intercept at -2. Okay, it does have an x-intercept at -2. That's true. And it passes through the point 1, 4. Hey, right off the bat, yeah, that's true. But because we're good young math Padawans, we're going to check all the rest of them. Letter B has an x-intercept at -2. That's true. We've established that. and it passes through the point negative 1, 4. No, that's not true. It passes through positive 1, 4. So that was the part that makes it incorrect. And then letter C and D, well, these are not the correct x-intercepts. We know that it has an x-intercept at negative 2, not at positive 2, and not at positive 1. So A really is the correct answer there. Last page, number 21. Graph g of x equals negative times x minus 2 times x minus 1 times x plus 3. I do not have enough room to work in there, so I'm going to go back to my scratch paper and set it up. So this was number 21. So I'll put C scratch paper for this part. Okay. All right, so I'm going to have g of x equals negative x minus 2 times x minus 1 times x plus 3. Okay, so let's notice some things before I get into graphing. First of all, it's going to have an x times an x times an x. So it's going to be a cubic. And because of this negative, that means it's going to be a negative cubic. So that means that my end behaviors are going to look like this, up on the left and down on the right. Okay, I need to know that. Also, from the factors there, because they gave it to me in factored form, I can break apart those factors and I can see what the zeros are going to be. I'm going to have a 0 at x equals 2, x equals 1, and x equals negative 3. If I solve each of those factors for set them equal to 0 and solve. Okay. All right, so I think we're going to have enough information here. The only thing I'm missing is the y-intercept. We can find the y-intercept by multiplying this out all the way. So if I do that, we have to do 2 at a time. So let me switch to a different color. So I do want my y-intercept. And so I'll have, if I multiply those, x squared, x times 3 is 3x. I'm going to keep that in my brain. Negative 1 times x is negative 1x. So 3x minus 1x is a positive 2x. And negative 1 times 3 is a negative 3. And then we'll multiply in the x minus 2 next. So that would be x times x squared is an x cubed. X times 2x is a 2x squared. X times negative 3 is a negative 3x. Negative 2 times x squared is a negative 2x squared. Negative 2 times 2x is a negative 4x. Negative 2 times negative 3 is a positive 6. So I have x cubed, the x squareds cancel, minus 7x plus 6. And there's a negative out front. So this is really negative x squared plus 7x minus 6. Okay, now I can see what my y-intercept is. It's a negative 6. Okay, so multiplying it out, it just takes a minute to do it. It's not that big of a deal, but it's nice to know what that y-intercept is. It'll help us when we get to the graph. All right, we are ready to graph. So I'm going to draw it. It's nice having graph paper because then it makes it a little bit easier to try to draw straight lines without a ruler. But we could always pull out a ruler or a straight edge and get it done. Get her done. Okay, so let's see. Since my zeros are 1, 2, and negative 3, I'm going to space them out. So this will be 1. I'm going to make my graph pretty. Negative 1, negative 2, negative 3. My y's, I'm just going to count by 1 since I know that I need to go at least to a negative 6. So, or you know what, I'll count by the evens. 2, 4, 6, 8, 10, 12, negative 2, negative 4, negative 6, negative 8, negative 10, negative 12. Okay, all right, my graph is ready to graph something on it. Okay, so we have a y-intercept at negative 6. I have an x-intercept at a positive 2, at positive 1, and at negative 3. And remember, this is a cubic. We already know the end behavior. We know it's going to go up on the left, so I can do this. And I know it's going to go down on the right. So on the very far end, 0, I can make this one go down. So I at least know that. I just got to figure out what's going on in the middle. Now, knowing how these cubics go, I know it should be going down. It'll go through the y-intercept, go through the 1, and then it'll come up and back down. So I could fake it, but no, we need to know where it's going through. Okay, so I need to make a little tiny t-chart and find those points. So between -3 and +1 would be -1. So I'm going to try a -1. And between 1 and 2 is a 1.5, 1.5. So I'm going to try 1.5. Okay. And we'll plug it into factored form because it's way easier to plug something into factored form than into standard form. We'll be able to do the math a little bit quicker in our heads. So let's try -1. So there's a negative out front. -1 minus 2 is a -3. -1 minus 1 is a -2. -1 plus 3 is a +2. So I have 3 negatives there. A negative times a negative is positive. But then I'm going to have that oddball out negative, so the answer is going to be a negative. 3 times 2 is 6. 6 times 2 is 12. So it's a -12. -1, -12. Okay, so I know that I'm coming down here. I'm going to go through the y-intercept and then up to that 1. Now I got to figure out how high up am I going to go in between the 1 and the 2. So that's where we plug in the 1.5. So it has a negative out front. And 1.5 minus 2 is a -0.5. 1.5 minus 1 is a +0.5. And 1.5 plus 3 is a 4.5. Negative times negative is positive, so this answer is going to be positive. I'm going to pull up my calculator. 0.5 times 0.5 is a quarter. 0.5 times 0.5 is 0.25, a quarter, and then times 4.5 is 1.125. Really, 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 really small. A little bit above the 1 line. So I counted by 2's on the y's, so my 1 would be halfway between 0 and 2. So 1.125 would be approximately right here. So it's just going whoop, and there's my graph. And you can double check that on Desmos, but still, this is the type of work that I'm going to expect to see. Okay, multiplying out that polynomial to get the y-intercept, identifying the zeros, identifying that it's a negative cubic function and what the end behavior would look like, and then a table of values of just the values that we need to complete the graph. And that was 21. Back to the packet. Number 22, which of the following represents a quadratic function? I'm going to pause there for a second. A quadratic function means that we're talking about an x squared. That means we're talking about a parabola. Okay? And it has zeros at x equals -3 and x equals 1. Okay. If these are the zeros, that means that the coordinate when x equals -3 would be -3, 0. And the coordinate when x equals 1 would be 1, 0, because these are, points on the x-axis. So let's look at these tables. Do we have a point -3, 0? No, this one has -3, 3. Incorrect. So it's not A. Let's look at this one. Oh, this one has a -3, 0. Does it have the 1, 0? Yes, it does. Okay, so it could be B. Let's try letter C. C and D are in factored form. Well, what would the factors be? Well, let's take a look. A factor when x equals -3 would be x plus 3. Okay, that one has the x plus 3. This one has an x minus 3, so automatically it's not going to be D. X equals 1. Its factor would be an x minus 1. Well, this one had the x minus 1, but we already canceled it out because it didn't have the x plus 3. This one has an x plus 1, and that's incorrect. So that means it's not C. So it really is letter B. The table had the correct information on it this time. Number 23 says the graph of a polynomial function p of x is shown. Which of the following must be a factor of p of x? Select all that apply. So if we're looking for the factors, that means we need to look for the zeros. There's a 0 at -1, so we have x equals -1. We have a 0 at x equals +2. And we have a 0 at x equals +4. So in factored form, x equals -1 would come from an x plus 1. X plus 1 is right there. X equals 2. That would come from a factor of x minus 2. And that one is the first one there. And x equals 4. That would come from a factor of x minus 4. So that would be this factor right here. Number 24. The graph shows the function f of x equals x cubed minus 2x. Is that a squared? Yeah, I think that's a typo right there. This is a cubic, so this should be a squared. X cubed minus 2x squared minus x plus 2 in the xy plane. What is the solution to the inequality? X cubed minus 2x squared, there it is again, minus x plus 2 greater than 0. Greater than 0 means we have to be above the x-axis. In review number 1, we could be on the x-axis and above because it was greater than or equal to 0. But now it just says greater than 0, so we're strictly above the x-axis. Where are we strictly above the x-axis? Well, there's a couple spots here. I see we're above the x-axis right here. And we're above the x-axis right here. Okay, so we have to say what intervals those are. Well, the first interval that we are above the x-axis is from an x value of -1 to +1. So since it's an in-between statement, this one would be an x in between. So we put less than signs around it, and because we can't equal these numbers because it has to be strictly greater than 0, and it always goes smallest to biggest from left to right. So -1 to +1. Okay, and then for the other side, we're at an x value of 2, but we're using numbers to the right of 2. So that means we need numbers bigger than 2. We can't equal 2, but they can be bigger than 2. So there were 2 solutions to this one. So let's graph that on the number line. So -1 less than x less than 1. So because it's not or equal to, that means I have an open circle at -1 and an open circle at +1, and x is in between, so we just connect them. Make it look like a barbell, like a weight. And then x greater than 2. I can't equal the 2, so that's an open point. But numbers greater than 2 are to the right. Now, if you have trouble telling which one's less than, which one's greater than, the greater than symbol points to the right. The less than symbol points to the left. So think left, less than, so the other one has to be to the right. Okay. And that's it.